Hello, my name is Leslie, and today I'm going to be talking about a few key features of GitHub Advanced Security that we think would be a great fit for your organization based on the discussions we've had so far around your security needs. The plan for today is for me to go through a couple of high-level slides to set the stage, and then move on into more of the meat and potatoes of the presentation, which is a demonstration of the features. That's the exciting and fun part. Before we get going, I do want to say if you have any questions over the course of this presentation, don't hesitate to just stop me and ask. I'll do the best that I can to give you an answer, and if I'm unable to, I will do some research offline and follow up with you after the call. All right, so GitHub Advanced Security is really based around the concept of shifting security left. And what this means is we don't want security to be an afterthought. We don't want vulnerabilities to make it into production and then cause a fire drill for your organization. Instead, we want security to be infused throughout every step of the development lifecycle. And you can see why this is important. There are a lot more developers out there than there are security researchers, which means that the onus has to partially fall on the developer to think about security, to make sure vulnerabilities don't escape into the wild where they may or may not be caught by security researchers. With this in mind, we don't want to just make it possible for developers to do this, we want to make it easy and intuitive. We want to make it a very natural part of the development lifecycle. So with this in mind, I'm going to talk about the features of GAS that we'll be looking at today and the ways in which they can really help your developers achieve this. The first feature that I want to talk about is secret scanning. Secret scanning is just what it sounds like. It scans your code base, not just at head, but your entire history to see if there are any secrets that match patterns it is aware of. And there are a couple of ways that these patterns come into play. The first is through GitHub's partner program. This is a really very unique to GitHub thing where we partner with, I think, around 180 companies, and they tell us their secret patterns. So we can bake those patterns into secret scanning, and by default, secret scanning just looks for them. These are super high confidence patterns, so if you get a match based on one of these partner program patterns, you can be very, very confident that that is an actual secret that is exposed in the code base. Low false positive rate. The other option that you have is private secret scanning, wherein you define your own patterns that secret scanning can scan for. So if you have any internal kind of secret patterns, this would be a great fit for you. The last thing that I want to talk about in terms of secret scanning before we move on is a feature called push protection. I love push protection because no matter where your developers are working, whether they're in their local IDE, whether they're in a cloud IDE, if they're in their terminal locally, push protection is a pre-receive hook on the server side that checks that code, again, no matter where it's coming from, and looks for secrets in it. And if it contains secrets, if anything is detected, that push is blocked. So those problematic secrets that, again, cause fire drills when they make it to the server, they don't get there. They don't get the chance to make it. Now we understand that there are certain circumstances in which a developer may need to push a secret. For example, if they're trying to test something. And we do present an easy way for developers to bypass push protection in those scenarios. All right, so that's secret scanning. Moving on to code scanning. Code scanning is static analysis. Basically, it is just scanning a database of your code to look for known vulnerabilities and creating alerts based on anything it finds. You have a couple of options here with code scanning. The first is to use kind of the default, which is CodeQL. CodeQL is a query language that was acquired by GitHub along with a company called Simul back in 2019. GitHub went ahead and open sourced the language, so it is supported by a vibrant community of security researchers and has a really robust set of default queries for scanning your code base. The other option you have is if you have a static analysis tool that you already love and you do not want to let go of, that is fine. As long as that tool outputs a serif compatible file, you can just upload that file to GitHub and see your results there. So those are kind of the two paths for choosing your own adventure with code scanning. Next thing I want to talk about is dependency review. Dependency review is different from Dependabot. I like to highlight this just to make sure no one gets confused, because I think, yes, we spoke previously and you all do have Dependabot enabled on some of your repositories. Okay, that's great. That's great. So you may be aware that Dependabot scans the default branch of your repository and looks for any issues based on its advisory database and then opens alerts based on that. But again, in the spirit of shifting security left, we would like to catch these issues before they make it into your default branch. So with that in mind, dependency review is an action that you can run as part of pull request validation to look at any new or updated dependencies that are included with that pull request and determine whether there are any issues. It uses the same advisory database as Dependabot. It's very similar, just again, happening a little bit earlier. And of course, you can fail the pull request based on the failure of this action and prevent those issues from making it into your default branch. Dependency review will look at your direct dependencies, of course, but it will also look at any indirect dependencies that you have in lock files. And the final thing to call out here is dependency review has a neat feature called license compliance, where if there's a license, say Apache 2.0, that you do not want to include in your organization, like you don't want any dependencies with that license to be ingested, you can specify a block list in dependency review and add that license to that list. And dependency review will check, again, in PRs to see, hey, do any of these new dependencies have this license? Okay, I'm going to fail and block this pull request. All right, so that is dependency review. To kind of bring everything together, the final feature that we're going to talk about is the security overview. Now you can see this at the org level, where you can get a lot of really helpful metrics for understanding the security status of your organization. You can also take a look at this at the repo level. It's a little bit less detailed, but it is kind of a good gateway for you to start resolving issues for a particular repo. So if no one has any questions, no questions? Okay, we can go ahead and move on and take a look at the security overview page. All right, so I am at the organization level. This is an organization called Octodemo that we have created to be purposefully pretty vulnerable. So you'll see a lot going on here. And you can see that I'm filtering by the past month. That's the default. And you can see my open alerts, not only just alerts over time, but the severity of those alerts as well. So this is kind of interesting to track how many open alerts of each severity you have at any given time. You can look at your average age of alerts. You can look at secrets that are bypassed. I mentioned push protection. So this tracks when secrets are bypassed and highlights it here for you. Mean time to remediation, just a lot of really great information to kind of help you understand how your org is looking in terms of security alerts and perhaps where you need to focus your attention the most. There are other views that you can click into. You can look at your risk based on the different tools that we've talked about and broken out by repository as well. And a similar kind of coverage tab here where you can see which tools are enabled for which repositories. That is the organization level. We can go ahead and move to the repo level. This is a repository that I created to demonstrate gas features. And you can see, like I said, at the repo level, there's a little less information, but you can at least see that I have everything enabled here, but perhaps some repos in your organization won't. And this could be good food for thought, like, oh, I don't have Dependabot enabled. Maybe I should go ahead and do that. And then this side panel is probably going to be the most useful part of the repository overview because it allows you to click in and easily see your open alerts for different tooling. So we're not going to talk too much about Dependabot because I know you already have that enabled, but you're probably aware you can see your Dependabot alerts here. For code scanning, you can see a very similar view of all the alerts that have been raised. They are organized by severity, so starting with the most severe, going down to the least severe. You can also see some information about the tools that are running to raise these alerts. So we can see that CodeQL is actually experiencing some issues. So let's go ahead and click in and see what's going on there. So it looks like there's an issue with some JavaScript files uh-oh, due to syntax errors. So this is something that we would definitely want to fix, both to ensure that our code compiles as expected and is scanned as we would like it to be. So that's kind of the tooling alert information. And then, of course, there's this secret scanning panel as well, and we're going to jump in and start talking about that feature right now. So I've gone ahead and clicked into that alert that you just saw. And this is actually contraseña, believe that's Spanish for password, but this is a custom pattern that has been defined in this repository. So we can click in here and take a look at that. And this is the update pattern page where you can see some information about alerts that have been raised with this pattern, the format, anything that you want to detect before or after. You can do a test string and a dry run, I like to call out, just to make sure that things are working as expected before you go ahead and publish changes. And then if you were just going to create a new pattern, you would go to Code Security and Analysis. You would scroll down to this list of patterns and you would click this new pattern button. And there you go. That's your new pattern that you can define. All right, so going back to the secret itself, you can see this possibly active designation. I like to call this out because there are certain secrets that we can't determine whether they're actually active or not, and a custom pattern is a good example of where we can't say for sure, right? Because this isn't one of our partner patterns. This is something that you have defined, and it's not something that we can say for sure is active. However, with certain partners, which I believe are AWS, Slack, Google, and Microsoft at this time, we can say this secret is active or it's not active, which can be helpful for you in triaging and deciding which of these alerts you need to tackle first. We show the remediation steps to take to go ahead and get this secret out of the code base. And we show exactly where it is. We show the commit that added it, and we show the contributor as well who added the secret. All right, so I think that is all on the secret alerts. So I'm going to jump into this secrets.md file. You can see I had a little typo there, but say I'm a developer and I have decided that to make things easier for folks in our organization, I'm going to create a new inventory of all of our secrets. Just, going to put it out on the server in the repo so folks can take a look at them and use them as needed. So cool. I've got my new secrets.md file. I'm going to go ahead and add it, and then I'm going to commit it. All right, then I'm going to go ahead and push it. All right, and you can see push protection has blocked this because of course it contains a secret. So it's saying, please get rid of this before you try to push again. I like to call out that you can update this URL to whatever link you want to send folks in your organization to give them details on how to handle this type of push protection block. You can see here that the secret is a Stripe API key. You can see the commit where it was added and the file and line number. So this alone should make it really easy to go ahead and amend that commit and remove the secret from it. However, if I do want to allow myself to push the secret, this is the link to go ahead and bypass push protection. Alrighty, so that is about it in terms of secret scanning. We can go ahead and move on to code scanning. You can see I'm back on the code scanning alerts page here. And I have all of these alerts as pointed out and their severity. So we can go ahead and click into this first one. You can see we unfortunately have some hard-coded credentials here. And of course, this is a problematic issue. You can see the branches that are impacted. You can see a brief description of why this is problematic in terms of leakages and attackers using it for nefarious purposes. And if you click show more, you can get a recommendation for how to fix the issue along with a legitimate code example saying like, okay, like here's the bad way of doing things, here's a better way of doing things, and some additional references in case you want to dive a little bit deeper. I also like to call out that if you want to track these alerts with issues, you can go ahead and click this create issue button, and it will go ahead and create an issue on your behalf to track it. Finally, if you decide that this isn't really important and you don't need to fix it, you can say won't fix, not important, and dismiss the alert. Now let's say someone decided, wait a second, that is actually pretty important. We don't want to be exposing that. Well, that is all tracked here in the closed alerts. You can go ahead and click back in and reopen the alert like so. All right, so next up, I want to talk a little bit about the serif component of all of this. So instead of starting here, actually, let me go ahead and click into this SL scan workflow, and we'll take a look at the workflow file. SL stands for Shift Left, which is a company that I believe has rebranded themselves to Quiet, but their organization is still called Shift Left Security. That's where the scan action is. So just to erase any confusion there, Quiet, Shift Left, same thing. Anyway, we are running a quick checkout to check out the repository, and then we are performing our scan. We are outputting a serif file called reports, and then we're uploading the serif as part of this action. So that's what happens with the SL scan, and then those results are shown back where we started here. And you can see if we click into this alert, it's a little bit different than the one we saw with CodeQL. There isn't the nice kind of recommendation and the code examples and things like that, but you do at least get the alert. The severity here is determined by how it's recorded in the serif file. So in this case, it was recorded as an error, and that is about all. You can still dismiss alerts in terms of the alerts that are uploaded with the serif files. So that is about that. All right. The last piece for code scanning is something that's really new and exciting. It was just announced very recently, and it's one of my favorite features of Advanced Security all up. So you can see here, I've created this pull request, and Advanced Security has actually detected in my diff that I have added a potential code injection vulnerability. And so it is commenting directly on my pull request. Again, this is before we make it to the default branch at all. It's saying, hey, this is a problem, here's why it's a problem, and look at this. This is a suggestion for exactly how to fix it. And if I wanted to commit it, I would just select commit fix and commit changes. And then that is all taken care of for me. All right. Finally, moving into dependency review, you can see that I have another PR open here. This time I was trying to add the PDF to HTML dependency. I thought, hey, this might be a useful thing to have in the project. So I went ahead and added it here, but unfortunately, pull request validation seems to have failed. So if we click into that, we can see that dependency review failed because I have blocked the Apache 2.0 license in this repo as part of my dependency review. And this PDF to HTML dependency has that license. So dependency review caught it, said, hey, that's an incompatible license, gonna fail the pull request. All right, so I believe we've covered everything that I had planned for today, but if you have any questions at all, please feel free to ask. I am happy to answer them.